Almost there. I want to give you a better explanation, and I think this will help. Okay. I'm going to try to eliminate a little bit of confusion here. So, if we have something like this, P and Q, if then Q R, anytime you have these sorts of things right here, they always take precedent over the operation itself, over an arrow or two arrows. You can always use parentheses. That's all they're telling you. That's it. That's all they're saying. So if I have P and Q, therefore R, the place I can use parentheses? Yes, right here. That's all they're saying. Okay, so are there any questions about that part so far? Sure there are. So let me say this, since there's no way to say anything. Just keep it. You get to have the chart, and you should be able to look it up. Now, let's put some of this to use. Let's actually try one of these with some words. Before we do that, I'm going to try to simplify things and say, oh no, please don't do that again, because last time it was too confusing. Look, I made it that way, shouldn't have. If I say P equals it is raining today, not P would be what? It's not raining today. It's that simple. P, if it's not raining today, then the sun is out. So, if it's not raining P and Q, the sun is out, then it's Q, like that. It's pretty simple. So, if it's not raining, then the sun is out. And that has to make sense, because that's what it should be. Now, you're going to say, well, there are always exceptions, but this is just a general example. Yeah, I know it can rain, and the sun can be out, but based on what I wrote here, P, it is raining today. P is raining today. So I could put then Q is cloudy, and if it's not raining, then the sun is out. So you just build them any way you want. Try to make them easy as you can. Told you that this would not be your favorite class. All right, so now look, it says here the truth value of each simple statement to determine the truth value of the compound statement. The American Idol ended its 15th season running in spring of 2016. Q, there are no singing contests left on network TV. Trent Harmon was the winner of the final season. So look, now we're going to use some of this truth table stuff. P says the American show ended 15 running season in 2016. Now this is or. It says there are no singing contests left on the network. Therefore, Trent Harmon was the winner of the last season. Now, if Q is true, but I don't think it is, I think there's still, contests on TV. Well, maybe not during COVID, but there have been. So this is what they say. Idol in fact did air the last episode in 2016. So that's true. But the Q statement, that there are no contests on TV at all, is false. So it makes the one part is true, the other part is not going to be. But when we use the conjunction or, it says, now we can analyze it since we have a compound statement. First, according to hierarchy of connectives, you can put that in parentheses. Remember, we talked about that. Now it's in parentheses. You can see what I'm doing. The disjunction should be evaluated P or Q. So if just one of those is true, then it's true. And that's how you got to look at it. Now, you're going to say, well, it really doesn't work. But in terms of, if you've watched a lot of Star Trek and some of the other logical people out there like Spock, or whoever used to be, they would do stuff like this, and it makes sense. All right, that's 3-2. Now they're going to get more complicated. Let's go to the next one. I think it's 3-3. The types of statements. Tautologies, self-contradictions, and logical equivalence. All right, so let's look at a tautology. It is a compound statement that's always true, regardless of the truth values of the statement. A self-contradiction is always false. Now, does that mean anything to you? All it probably means to you is that a tautology, whatever that statement is going to be true. That's what he says. He says a self-contradiction is always false. So let's look at some. I'm going to a metal concert, and Q, I'll wear black leather. So see if it's a tautology. Well, P and then Q, that's true. Therefore, P is true. It says, I'm going to a metal concert, assuming that's true, and I'll wear black leather. So look at this. B. Look at B. So let's look at it on the table. We said the first two columns are easy. First column of P, either TT or FF. The second one, Q, is always going to be either the opposite, so that you have a true and a false and a false true and a true false. So they write TF. Now, does it have to be in that order? No. It could be in any order as long as you have the same combinations. Now, when P or Q is true, they're always going to be true. That's why we call it a tautology. It doesn't matter. As long as one of those is true, it's true. Except for in the case it's when it's F, it's also going to be true. I'm not going to wear, or say, so how would that read? F, P would read, I'm not going to the metal concert. I'm not going to wear my black leather outfit. Let's see. So those both are false. In order for this to be true, one of them had to be true, but they weren't normally. But in a tautology, it is. So this is one you've got to look at and note. This is a little bit different. Let's see if it's on the chart I sent you. Let's see. On page 34, what I sent you. And if you look at it, you'll see on page 34, they're all true. That chart will help you. So you shouldn't have any issues. The only thing you have to note that is when you see it like in column 4, no matter what, they're all true. That's a tautology. Now think about it. Why would that be true? I'm not going to go to the concert. Well, let me start out. Let's start with the right one here. I'm going to a metal concert. I'm going to wear black leather. If that one's P is false, I'm not going to the concert, I'm not going to wear black leather, then everything that you say is false, but makes it true. I'm not going to wear black leather, therefore I'm not going to go to the concert. I'm not going to the concert, therefore I'm not going to wear black leather. Again, it's kind of mind-boggling stuff, and again, I assure you, we have this one more section of this stuff left. But it makes sense to me because they're both false, and that's false. The or part, it makes it true. John is not 6 foot tall. Anyway, now here's a more complicated chart. We noted that in a situation, no matter what, if everything is false, we call that a self-contradiction. Notice that they build this chart. They do not include the parenthesis P or Q. And Q, then P. They don't include this fourth column. It's not in this one. But they include the P and Q and the not P and not Q. In this case, you just keep this chart. Notice that the 1, 2, 3, 4, 5, 6, the 7th column is always false, and you're asked, what does that mean when they're all false? Like this, it's a self-contradiction. Always